Doesn't want to work. I can't get the chat to work. And if I can't get the chat to work, this is a huge issue. It just worked. Oh, looks like it works. I just did. See if you're seeing it from your side. Hmm? What was just okay? Yeah, next time I have to make sure that I cancel everything like 2 hours before. And I can't have anything next to. You're gonna be able to see this? Okay, guys, I think we're officially live. It only took me 45 minutes to get fully set up. Actually, it took more like an hour and a half to get fully set up. But we are running 40 minutes behind schedule, which is all sorts of fantastic. But hopefully this works and it shouldn't be too much of an issue. It shouldn't be too much of an issue. So I'd like. Oh, that's what I'm thinking was. Okay, guys, let's get started. I'm having serious technical issues today. Okay, regardless of the situation, let's get cracking. Okay, this is the problem that we left off on last time. Okay, so whenever you see these type of problem, by the way, the chat should be working this time. So if you guys have any particular questions, okay, let me know. For those of you who are tuning in or just scrolling past and looking for specific YouTube lives, this is Infinite Academics live YouTube channel. Okay, we're giving away free, totally free SAT prep, breaking down each and every single concept, making sure you guys fully understand exactly what to do, how to do it, and so on and so forth. So I'm going to be doing this live every Monday, 7 p.m. Make sure to subscribe to our channel and let us know if you have any particular questions. Again, I will be answering everything you could possibly have as we keep going along with this. Okay, let me make sure I'm fully set up. Cool, let's go through this. So first thing you know, when you see this type of question, immediately, this is question 20, module 2, gonna be difficult, all right? So you should have an idea. I mean, this is 100% a circle problem. Now, you could do this problem by hand. You could do this problem on Desmos. I always recommend to do them on Desmos because Desmos by far is the easiest and best way to do this. Now, if I was going to do it on Desmos, I would just go into a calculator right here. I'm going to move this over so I can see the screen. So I'll go x squared, right, minus 4x plus y squared plus 5 over 2. I'll have the y. Make sure you're not putting the y next to the 2y because that'll be a problem. Equals 5. Okay, and immediately give you that. And if you notice there are like specific points, little dots right here, see it'll give you the highest most point and the lowest. And I'm just clicking on it. Okay, for those of you who are on the Facebook Live, you guys can actually see my fingers, or you should be able to see my fingers, so you'll let me know if anything as far as that's concerned. And then if you take a look at this, I can immediately find the center, or I can find the distance between them, which will essentially give me my radius, okay, or specifically my diameter. Okay, it's the easiest way to actually solve this out. So let's say, for example, if I am, okay, this isn't clicking, which is all sorts of fun. Oh, there we go. Okay, iPad went a little nuts. Again, technical issues today. That's to an extreme. So let's just say, for example, I don't know what I'm looking for here. The center. Okay, so I just want the center. So if I'm going to do the center, I just want to find midpoint. And if I'm specifically looking for midpoints, I would go functions. I'd scroll down, or I could just type in midpoint, like I'm fully aware for those of you who are really, really understand midpoint. But then I'm just literally looking for midpoint, and it's usually kind of forgot where it was. Where is it? Mean, medium, max. It should be in definitely past it here, midpoint, geometry. See that? And then I'm going to type in my 2 points, so it's 2, 2. So I'll put parentheses around it, 2, comma, 2. Close the parentheses, then I'll put another comma here, parentheses, and then I'll put in the other point, which is 2, negative 4.5, 2, and negative 4.5. Oops, negative 4.5, perfect. So immediately I get the center, which is 2, negative 1.25. Since I'm looking for h plus k, it's going to be 2 plus negative 1.25, or 0.75. Okay, so that should essentially be the answer, and that's without an issue. Now, if I was going to do this by hand, if, right, big if, and I'm going to just go ahead and break this down, I need to follow, I left the answer on the screen, but it's fine. So I need to follow the standard form, which is x minus h squared plus y minus k squared equals r squared, where h and k is a vertex. So now if you don't know this formula, this is the standard equation for a circle. You have to know the standard equation for a circle or it's going to be a problem. So how do I do that? You do complete in the square. That's the only way to do this. So an easy way to do this is you half the negative 4, plug that in immediately. Whatever's in front of the x has to stay in front of the x, kind of the rule. So if I half that, that just becomes x minus 2 squared plus half whatever's in front of the y. That's going to be y plus 5 over 4 squared. Okay, just literally shove that into here. Okay, nice and simple. And that's going to equal 5 plus the square plus the square. It's a cool little trick. So I'm going to do plus negative 2 squared plus 5 over 4 squared, which if I do that out, I get 5 plus 4 plus 25 over 16, okay? Which is kind of a crazy decimal, but it's fine. Okay, so if I do this, I'm going to get 9 plus 25 over 16. Oh boy. So that's what, like 144 over 16. So it's going to be 169 over 16. This is kind of gross, to say the least. I don't really care about the radius either way, because I only care about the center. Um, I only care about the center, right? So like even if I get 169 over 16, that's my r squared. Then I square root both sides. I get r equals 13 over 4. A lot of complicated math. Don't go crazy with this. It's not necessary because that would be the distance. I just need to find my center, which is 2 and negative 5 over 4, or 2 and negative 1.25. If I do that h plus k, 2 plus negative 1.25 is 0.75. So I'm done. Okay, that's all I'm really looking for, and it won't let me write the 75. So it's, again, just 0.75. Don't overcomplicate this. Again, do this on Desmos, easiest way to do this. Again, if you're just tuning in, okay, if you are just tuning in, let me know. Okay, let me know if you have any particular questions, if you want me to explain it in a different way, anything along those lines. I will going through every little detail, answering whatever questions you possibly want. Just let me know, put it into the chat, and I'll help as much as I possibly can. Okay, that's the end of that. Let's go into the next problem. In this situation, okay, immediately I'm looking at this question and I see sum of solutions. Now, when I'm dealing with sum or product, I always think of two things. I'm either thinking sum, which is negative b over a, or product is c over a. So that's a general idea here. Now, in this situation, there's only one way to do this, and that's going to be by hand. So let's be really clear. It's going to be product of solutions is c over a, and sum of solutions is negative b over a. And if I do that out, I get st over negative 52. And that's my product, okay? Since I need sum, it would be 13s minus 4t over d. That's my sum. So actually, I don't really even need this. I was just kind of showing you guys that that's product. So this is the sum of the solutions, right? Sum. But it also tells me the sum is supposed to be equal to this. So I can actually set them both to be the same. So 13s minus 4t over d, and they have to equal, right? So then what did I do here? The sum of the solutions, I don't know what I'm writing, guys. Sorry. That is my sum. That's exactly what I calculated for. And then 13s minus 4t over d, and that has to equal negative b over a, which this is my b, this is my a. So I'm going to get this equals 13s minus 4t over negative 52. Guys, you could clearly take a look, like 13s minus 4t equals 13s minus 4t, right? And then d has to just equal negative 52, and I'm done. Okay, it's very simply, the answer has to be d. So you got to be a little bit on the careful side. I kind of confused myself. This is positive 52. Oh, because I forgot to do negative b over a. Well, that was silly. Let me do that one more time, okay, just to give everybody an understanding of exactly how to do this. So if I do, again, sum is negative b over a. Don't screw up the signs like I just did. That's kind of bad. So if I do 13s minus 4t negative, technical issues have me all screwed up. 13s minus 4t over negative 52, and then I have to multiply this by negative, right? Because that's negative b over a. So, and that has to equal 13s minus 4t over d. So then what does the d have to be? The d has to actually be positive 52 because the negative times the negative cancels out. Okay, that's where that comes in. So be careful with that because I totally screwed that up and I don't want you to do the same on your exam. So anyway, let's keep pushing. Next, exponential functions. Whenever you see these, every single time you see these, please, please, please make sure plug in values. Okay, and you're going to plug in values directly from the actual graph. All right. So the way I would do this, I mean, you could technically do a tilde for those of you who are like significantly advanced when it comes to tilde. But the idea behind this is very simple. You're going to plug in points, and the way I would do this, I would definitely start out by doing this by hand, and I would use the points 0, 4. I would use the point -1, 2, and that's it. Okay, I think that should be enough. We'll see. So I'm going to follow this equation, right? Because that's the equation, y equals a times b to the x. A times b to the x. And now if I do that, I plug in 0, 4 first. So I get 4 equals a times b to the 0 power. B to the 0 power is 1, so I can cancel that out. So a is equal to 4. Cool, so I have a new equation. Y equals 4 times b to the x. Now I'm going to plug in -1, 2 because I used the 0, 4. So 2 equals 4 times b to -1, which is the same thing as 2 equals 4 over b. Times b, I get 2b equals 4. B is equal to 2. Cool, so I have an equation. Y equals my a, which is 4, times 2 to the x power. Fantastic. Now what is it asking me for? It's asking for h of x, which is k of x minus 3. So I'll plug in x minus 3 into here. So if I do the k of x minus 3, which is my h of x, by the way, all I'm doing, it's a function. You just plug it in. So it becomes 2 to the power of x minus 3, which I forgot about the 4, which you have to understand what -3 means. If I really think about what 2 to the x minus 3 means, because I already know what they're going to do with this, they're going to try to simplify this. So whenever you see these complex exponents, you want to simplify them to the simplest base form. So 4 is the same thing as 2 squared. 2 is 2 to the x minus 3 is basically like 2 to the x divided by 2 to the third power, right? Because division means subtraction when it comes to exponents, right? We don't need logs or anything like that, but we definitely need that here. So if I do that out, this is the same thing as 2 squared times 2 to the x divided by 2 to the third power. 2 squared to 2 to the third power, I'm just left with 2 to the bottom. So it basically becomes 2 to the x power divided by 2 to the first power, which is 2 to the x minus 1. That should be my answer, okay? 2 to the x minus 1. If I look at that here, I get 2 to the x minus 1, which is d, right? So be careful with this. A little bit on the tricky side. Definitely on the tricky side. Okay, let me see if it's zooming out. You guys should be able to see that. Well, anyway, now you do. So just be a little bit on the careful side. There is another way to do this on Desmos. I'm actually going to go ahead and plug that into Desmos. Let's see. If I'm looking at this, actually another way to do this, you know what I just thought of? This is also a transformation. So you need to understand that when you're dealing with transformations, okay, so if I have, let's say, for example, f of x plus c, f of x minus c, f of x plus c, and f of x minus c. So you need to understand transformation rules means you're moving the graph like around. All right, in this case, I'm moving it left c spaces, right c spaces, up c spaces, down c spaces. Okay, that's the idea. And in this case, since I'm looking for something moving to the right 3 spaces, I'm literally just going to take this point and move it to the right. 1, 2, 3. And I'm going to take this point and move it to the right. 1, 2, 3. So it's going to look something like this. And then I'm going to graph out each one using Desmos to see which one literally moves 3 spaces to the right. That's it. That's how I would do this on Desmos. Honestly, that, in my opinion, is my favorite way of doing this. There is one more way of doing it using the tilde to create a custom regression here. That, in my opinion, is more complicated than just doing the transformation or even doing it by hand. Yeah, doing it by hand. So I won't even go there. Okay, I won't even go there because I'm going to confuse everybody. And let's not do that. Let's keep the simplest way. Okay. Just because you can use Desmos doesn't mean sometimes you should. So just a warning as far as that's concerned. Next, the dot plot represents the 20 values in dataset A. Dataset B is created by taking all values from dataset A and adding. Guys, for those of you on Facebook, by the way, for the best way to see exactly what I'm doing is on our YouTube Live. Infinite Academics YouTube Live, that's where we're at. Okay, if you have any questions, let me know, type it into the chat. But the YouTube Live is really where the place to be. That is, my opinion, the best way to do this. And think about this, okay? Because you'll be able to see exactly what I'm doing and you can communicate me with effectively. Because if anybody's typing into the Facebook Live, I have no idea what's going on there. So anyway, the dot plot represents 20 values in dataset A. Dataset B is created by taking all the values from dataset A and adding a single value 20. Which of the following correctly compares the medians and the means of dataset A and B? All right, well, I mean, you have to, I would find out each one. All right, and I would find out each one by literally just typing them all into Desmos. Okay, I'm gonna have to whip out the the keyboard for this one. Okay, so I have a keyboard here. For those of you on Facebook Live, again, I would highly recommend to please join our. Oops, yeah, this is the only issue with that. Please join the YouTube Live, okay, because that way you can see exactly what's going on. So I'll try. I'll try to turn this in the best way I can. Long story short, I had calculator. There's still information from the previous problem, and I would literally find my mean median by literally typing in all the values. So I get 17, 1, 2, 3, 4, 5, 6, 7. So 17 7 times. 2, 3, 4, 5, 6, 7. Yeah, it's annoying, but there's no better way to do this in my opinion. 1, 2, 3, 4. I mean, I could do this logically. I don't think it's the most efficient way to do this because what if you're wrong? You know what I mean? Like it's always going to be in the back of my mind. I would never think let's put it this way. I would never rely on just pure logic or reason but to answer my question. I would want to prove it with actual data. 2, 3, 4, then 23 two times, then 25 three times. Cool. So that is my mean, okay, which is totally fine. And now what happens if I add a single value 20 to this? So I'll just put 20 right in the middle. It doesn't really matter what I'm doing with this. So if you look, the mean doesn't change at all. All right, so that's kind of interesting. So the means are exactly the same. Now I just define the median. And the way I would do that is I would literally just type in median. Okay, and the median here is 19. And if I get rid of the 20, I get 19. Okay, so the medians are going to be the same and the means are going to be the same. So, I mean, what do you think the answer is? Okay, I mean, it's pretty straightforward as far as that's concerned. And I don't know if I would be able to logically reason this out. I think you're going to have to do the math either way. That's just the way I see it. And Desmos makes it so easy, so that really shouldn't be much of a problem. Anyway, 16. Obviously, I'm working my way backwards here because last week I started off. I started off with the module 2 reading, and we really got into that. And then I was like, okay, let me do the last 2 questions on math module 2. In this case, I'm continuing exactly where we left off last week. Okay, so I'm looking at this. I mean, look, guys, we have a system equations. When we're dealing with systems equations, really, there's only a couple different types of problems that could possibly come up with systems. Either one is just a simple, straightforward system where you're going to use Desmos and look for the intersection point. I mean, that takes 3 seconds. The other possibility is, of course, in this case, is a discriminant, or it could be like a no solution, infinite solution problem. That's for lines. In this case, it's a quadratic. All quadratics are the same, especially in this situation. You are going to use discriminants. Okay, you are 100% going to use discriminants. So without a question, whether you want to do it by hand, do it by Desmos, I don't know. I'll do both ways. Whatever's faster, easier, depends on you. Okay, so that being said, if I'm looking at this, I get two equations. One of them is quadratic. I'm trying to do discriminant, trying to find number of solutions. In this case, it has one solution. So I know for all discriminant, if the discriminant is equal to 0, you get one solution. If the discriminant is less than 0, you get no solutions. If the discriminant is greater than 0, you get two solutions. Okay. So just to be really clear, this is one solution. And the way you solve it, because it's a system, you have to set them both equal to each other and get it equal to 0 before you solve anything. So again, set them equal to each other, get them equal to 0. So I'll do 3x equals 3x squared plus 15x plus c. Now I have to get it equal to 0. So subtract 3x on both sides. I get 3x squared plus 12x plus c equals 0. Cool. Now I can do discriminant. And discriminant is always equal to b squared minus 4ac and has to follow, well, the rules. Since I know it's one solution, I know it equals 0. So I'm going to go b squared, so that's 12 squared minus 4 times 3 times c, and that equals 0. Okay, so it's 144 minus 12c is equal to 0. I mean, I clearly see c is equal to 12, and I'm done. Okay, there's nothing else to do as far as that's concerned. In my opinion, by far the easiest way to do this. It's the most consistent and honestly the best. Okay, now for all you Desmos nuts out there, I will definitely do this using Desmos. Again, I'm gonna just whip out the keyboard because this is going to be annoying otherwise. And again, for anybody on Facebook, best way to look at this is on our YouTube live. So if I just type in this entire equation, I go, I don't even have to set them equal to each other. I could literally just type it in as is on Desmos, because then I'm just looking for the point of intersection where it's going to be 1. But you're going to have to use the slider here. So I'll do y equals 3x squared plus 15x plus c, right? So immediately ask me to make a slider. Sure. If it didn't, I would just literally click like c equals 0, let's just say, and I would get the slider here by pressing the play button. Okay. Now, since I'm looking for one particular solution, I know the answer is 12, so I'm going to click this little button, then 10. I'm going to set it equal to, well, that's too much. Let's make it 25. I'll set this and I'll make this 0, whatever. Okay, so I'll set it since I already know. I'm looking for the point where it's going to hit like one time, right? I mean, I know that the answer is going to be 12, right? Because we already did that by hand. But see how close it is? It's kind of why I don't want to do it on Desmos, because it kind of sucks, okay? It's so hard to see. You know what I mean? Like, how do I know that it only hits one time? I mean, I guess you could click on it. Again, not a big fan of doing this problem on Desmos. More of a big fan of doing it by hand, all right? But regardless of the situation, you can do it either way. So I'm totally good with that. Next, 15. Ooh, my favorite. These are what like the whole online community calls constant problems. Guys, I think that's a bunch of bullshit. Okay. Constant problems. And like half the problems have the word constant in them. Okay. They just caught fire because they literally have the word constant in them. Okay, that's irrelevant. I call these identifying equations because that's the actual term for them, because you have to identify what kind of the equation this is and set like equal like. I'm going to say it again, like equal like. So in other words, like coefficients have to equal each other. Anytime you have like a ax squared, has to equal a, right? A equals a on both sides of an equal sign. That's basically the idea. So let me show you in great detail. So let's say, for example, if I take this, it says that this basically can be factored into like all of this chaos, right? So a lot of people will immediately try to factor this, and that's like a big no-no. Like, do not do that. Okay, you factoring that would be an epic waste of time. But what you can do is you can FOIL this. So try to expand this out, okay? And you'll see it works quite well. What do I mean by that? So let's take a look. So if I have, let's say, for example, 3 parentheses, x minus k times x squared plus px plus q, and I'm going to set this equal to this, 3x cubed minus cx squared plus 27x plus 9, right? So what I'll do is, first things first, I'm going to distribute this out. Keep that simple. So I get 3x minus 3k times x squared plus px plus q equals that whole chaos, right? The right side, whatever. I don't have to rewrite it 50 times. You get the point. So if I take this and I just multiply everything by everything, right? That's what essentially foiling is. So if I do 3x times x, 3x cubed. 3x times px, 3px squared. 3x times q, 3qx. Distribute. 3k minus 3kx squared. Distribute. 3 minus 3pkx. Continue. 3kq, 3kq. Okay? That's basically the idea here. Now, how do I continue this out? So let's keep going. I have this whole chaos, right? And this is like the definition of chaos. If I look at the coefficient in front of x cubed, what's the coefficient in front of x cubed? 3. What's the coefficient in front of x cubed here? Also 3. I'm going to change the color. So 3 equals 3. Cool, that doesn't help me at all. What about my coefficient in front of x squared? Well, that's 3p. And then I have minus 3k. See, all the coefficients with an x squared have to equal all the coefficients with an x squared. Again, like equals like. So I have 3p minus 3k has to equal negative c. Why? Because that's a coefficient in front of x squared. Cool. So I got that part. Next, I'm going to go again. Now I'm going to look at all the coefficients in front of x, right? I'm going x to the third, x squared, x, and then just my actual constants. So I have 3q and minus 3p, k. So 3q minus 3pk equals 27. Cool. I got more stuff. Fun. Then, last but not least, I'm going to make that green. My constants equal constants. 9 equals negative 3kq. 9 equals negative 3kq. Fantastic. So now, what do I need to do? What is it asking for? Which of the following must be an integer? K, P, and Q are integer constants. Fantastic. Now, what can I do here? I can start solving everything out. Okay, I could. Or I can start looking at my answer choices and see if I can mess with something, right? So if I look at this and I go C over 3, that's interesting. Well, if I do look at my red equation, 3p minus 3k equals negative c. If I divide everything by 3, I get p minus k equals negative c over 3, right? But p and k are constants. So integer constants. So is an integer constant minus an integer constant always an integer constant? Yes. That's just a fact. Integer minus integer equals integer. It has to, right? 10 minus 3, 7. 15 minus 12, 3. It doesn't matter. And it doesn't matter whether it's negative or positive either, because it's still going to be an integer, right? Because negative 5 is still a negative, right? But it's still an integer. It changes nothing here. So the answer here is definitely B by far. You can just look at it right there, and you can see that this is clearly an integer. Now, that might have been a lot, because by hand, this problem is not exactly ideal. And by hand, you guys should be realizing that I'm implying the fact that this can be done on Desmos, because it can, okay? And if I'm going to do it on Desmos, let's break this down. How would I actually do this on Desmos? This is where you would use the tilde, okay? Just to be clear, the tilde is a little squiggly thing right above your tab key on any keyboard, okay? So if you look at the tab, you'll see a little squiggly line right there. You hit shift there. There's like a little apostrophe, backwards apostrophe, and then there's the tilde. So if I'm going to go ahead and open up the calculator, and I type in my entire equation, right? So I'm going to go, this is going to be a long one, 3x to the third power. Whoops, already screwed it up. Yeah, don't mistype it, because that'll be a disaster. Minus cx, because you'll get it wrong for no reason. Cx squared plus 27x minus 9. And use the tilde here. Okay, I'm going to use the tilde, and I'll explain why in a second, because you can't set an equal sign, long story short. You have too many variables. When I say this, when you have too many letters and not enough equations, you're using a tilde, okay? That's what the identifying equation problem requires. So tilde 3 parentheses x minus k, and then more parentheses. I had to go x squared plus px plus q. X squared plus px plus q. Now, for those of you Desmos, geniuses, I clearly made a mistake because I didn't put in the subscripts. Guys, for these problems, you always have to put in a subscript. So you have to put a little number 1 right next to all your x's. You must, okay? Or you will have a problem with this. So it's going to be x1. See that? x1, 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 1, and boom. Okay. Now, if you notice, you get a whole bunch of like 1, 1, 1, because tilde can't be used like that. Tilde's going to use like a really small or really large parameters if you don't actually set the parameters. So what we have to do is we have to set parameters by typing this in. And guys, to be clear, you always do the same exact thing. Okay. You're never going to change this in any possible way. You're going to go 1 dot 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 10. Okay. I think I used the wrong brackets actually. Yeah, I used the wrong brackets. Sorry. These brackets. Okay, see, it's going to give you 10 element list, and all of a sudden it's going to change all my values for P, K, Q, C. And that's it. That gives me the answers. So if I look at K over C, that's 1 over 21. Now that's a decimal. C over 3, 21 over 3. K, 21 over 3, 21 over 3. Why am I blanking? It's 7. Jesus. It's been a long day. It's been a really long day. So if I get 21 over 3, that's very simply just 7. I'm good there. I think I'm on Do Not Disturb, but apparently not. Awesome. Okay, so yeah, the general idea is quite simple, and that's the end of that. So let's keep going with this. Yeah, it's a super good one. Okay, super good one. Let's keep pushing through. 14. The average weight of a group of 20 people is 20 kilograms. Okay. If 5 more people join the group and the average weight remains the same, what is the total weight of the group now? Okay, so this is the typical average problem. And with the average problem, it can be a little bit funky, but the idea behind the average problem is you have to actually follow the formula down to the T. So how do I do that? Okay, you have to understand what average is. Average is the total over the number of numbers. Okay, so in this case, I have 20 people, 60 kilograms. So my average is 60. My total, we don't know, call it X. But I do know that there are 20 people. So if I multiply both sides by 20, the X, or the total weight of all the people, is 1200. Now, if I know the total weight is 1200, I can do 1200 plus the 5 more people. I'll call it, we'll call it, I don't know, person 1 plus 2, 3. You guys get the idea. Okay, 4, 5, right? Over, now I have not 20 people, but 25 people. And it says 5 more people join the group and the average weight remains the same. So it has to be, again, 60 kilograms. What is the total weight of the group now? Well, we can do this again. We can multiply by 25, multiply by 25, and we get, let's see, I need a calculator for this one. Let's see, 25 times 60. 25 times 60 is 1500. So I get 1500 equals 1200 plus this total of 5, right? Oh, 5 with a little circle. Minus 1200, minus 1200. I get 300 equals the total of 5, right? So then if I divide each one by 5, I only need the total weight. I'm done. Okay, so then it's just 300. Nice and simple. This is the only way I would do this. 5 people join the average weight. Oh, total weight of the group with 25 people. I apologize. You didn't even need to subtract it. You could have just done the just not the not you could have found it just the 25 people. So you can do 60 times 25, not the whole, not subtracted by the original 1200. That was unnecessary. But anyway, okay, pretty straightforward. 13. This is another discriminant problem. Again, I would do this by hand. I don't know if I would do this on Desmos. You could do this on Desmos. It's fine. You add the slider. But again, I would just do b squared minus 4ac, d squared minus 4 times 3 times 12. Guys, look how often discriminants come up on this exam. They literally come up all the time. One solution equals 0. So I go d squared minus, what is that, 144? Equals 0, d equals plus or minus 12, because if I add 144 in the square root, I get positive, negative. And in this case, d is a negative constant, so be careful. It's negative 12. Okay, don't make that careless mistake, because a lot of people get caught with that. Next, a sports store buys basketballs at wholesale price of $18 each and resells them at sale price that is 450% of the wholesale price. So it's not 450% increase, it's 450% of that, which means I'm literally just going to do 18 times 4.5. So I'll go ahead and do that, And if I do 18 times 4.5, I get 81. At the end of the quarter, the remaining basketballs are marked at a discount of 70% off. So 70% off means I'm subtracting because that's percent decrease. 1 minus the 0.7 or times 0.3. So times 0.3 is 24.3. What is the discounted price of each remaining basketball? That's it. Well, that's at $24.30. That should be the right answer. Okay, nice and simple. Notice how much easier the problems are getting once I get into like the 13, 14 range. 11, infinitely many solutions. Infinitely many just means same slope, same y-intercept. So I have to set everything to be the same. It's very similar to like identifying equations. So you should notice that. That's a good pattern. Anyway, I'm going to distribute this out, get into normal form, y equals mx to b form. Negative 3q x plus, I should have minus, but whatever. Negative 3qr equals negative 27 over 16x minus 45 over 24. 3q equals negative 27 over 16, negative 3q. Negative 27 over 16 and negative 3qr equals negative 45 over 24. If I divide both sides by negative 3, q equals, that's 9. That's 9. 9 over 16. And if I plug in 9 over 16 into here, I get negative 3 times 9 over 16 times r equals negative 45 over 24. So that's negative 27 r over 16 equals negative 45 over 24. Oh, what a pain in the ass. Divide both sides by 3. That's 15, negative 15 over h equals negative 27 over 16. Can I simplify that? I can't. Negative 27 over 16. I would have to multiply both sides by 16 over negative 27, which is a big pain. That's r. Yeah, so I got to do negative. So I got to do 15 times, rather 15 divided by 8. And then I'll do times 16 divided by 27. So I get 1.11111111. Is it positive or negative? Positive. Because everything is negative. Okay, so it's like a crazy, crazy number. Again, you could just shove it into Desmos from there. I just didn't want to whip out the keyboard at this point. Let's keep going. 10. The function d models the distance in kilometers a vehicle can travel on a single charge 2 years after its release. Cool. According to the model, the distance is predicted to increase s% every 30 months. Okay, best way to do this is just to figure out how many years is 30 months. So do like 30 divided by 12. I'm going to need decimals here. I have no other choice because I have too many crazy decimals here. So if I go 30, again, if you're just joining on YouTube Live, please join our, no, rather, if you're joining on Facebook Live, join our YouTube Live. That's where you can see everything that's going on, except my keyboard. I guess you can only see that on Facebook Live. Anyway, so if I do 30 divided by 12, which I can probably do in my head as 2.5, whatever. So now that I have 2.5, I'll plug in the whole thing, but I'm not going to include the 75. The 75 is the initial value, so I don't include that. So I'll go 0.92 to the, it's going to be 8 over 10 times, what did I say, 2.5? Yeah, so it's 0.8464. Now, don't be trapped into thinking it's 84% of the original value. No, it's actually a decrease of like 15.6%, right? Because it's 1 minus the 0.84, so it's going to be 15 something, and because it's in percent, so it's got to be D. So you got to be super, super careful with the wording here, because it's 84% decrease, but that's 15, rather, it's rather 84% of the original value, but that means it's a 15% decrease. That's what it is, because it's 84%, because we're multiplying by 0.4864. Just like the original one was a decrease of 8%. So that's a confusing concept, so be careful with this one. All right. If you're a little bit stuck, again, ask me in the comments, not an issue. Next, number 9. A cubic solid has a density of 1200 kilograms per cubic meter. The weight of the solid is blah, blah, blah. What is the length in inches? What is the edge length? I think this is, I don't think this is yeah, this is not a, I thought this was a dimensional analysis problem at first, but this doesn't look like it's dimensional analysis. This actually looks like it's flat out, just like a density problem. I mean, oh, that's not what I meant to do. This is what I meant to do. So if I do this, density is 1200. So I know density is equal to mass over volume. So that means 1200 is equal to the weight of the solid. Weight is not mass, but whatever. Okay, they're saying that the weight is the same thing as mass. That's not true, but let's move on. So that's 614.4 kg and over edge length in meters of the solid, but it's a cube, right? Cubic solid. I guess we don't really know. Yeah, we do. It's a cubic length. Okay, so let's call a cube since a volume. Volume of a cube is side cubed, or let's call it x cubed. So I can literally just do multiply x cubed, or just shove this whole thing into Desmos. I get 1200 x cubed equals 614.4. Divide 1200, divide 1200. I'm going to get, you know what? I'm just going to shove this whole thing into Desmos. It's much easier. So what is that? 1200 x cubed equals 614.4. 1200 x to the third power equals 614.4. 614.4. Now I gotta find it. There you go. And unfortunately, it doesn't give it to me right away, but I have to actually zoom in to see it. So that's just 0.8. 0.8, not 0.08. Yeah, that was a little bit tricky. Careful with this one. I don't think you have to be careful with this one. It's pretty straightforward. Number 8. Line M is defined by blah, 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 and is parallel to line M. Okay. Again, pretty easy. You just have to put this into y equals mx plus b form. That's the only annoying part here. So I'm going to do subtract 7x. I get 4y equals negative 7x minus 20. If I divide both sides by 4, I get y equals negative 7/4 x minus 5. I only care about parallel, so it's slope. So I know my slope is going to be negative 7/4 x. And I don't know what my y-intercept is. So that's the only annoying part. So plus b, but I know it passes to the 0.40. And if it passes to the 0.40, I'm going to plug in x for 4, y for 0. So 0 equals negative 7/4 times 4 plus b. These will cancel, so b is 7. Done. 7. In the figure, lines E and F are parallel. Okay. 7x plus 14. I can't see. I'm going to draw. So 7x plus 14. Cool. And W is 9x minus 20. Oh, well, I didn't really don't have to do that. You just set them equal to each other. There's nothing to do. The Y value is going to be 180 minus whatever that is. So you just got to be careful with that. So if I just shove them into Desmos, let's do it. So I know they equal to each other. So I got 7x plus 14 equals 9x minus 20. Okay, hit the home button. Where's my x value finally? My x value is 17. So I'll plug in 9x minus 29 times 17 minus 20, 133. And then I would just do 180 minus 133. Just don't screw up like the actual wording of it. So that's 47 because that would just be annoying. Okay. Careful with this one. 6. Function f blah 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 where c is a constant. Awesome. What is the value of c? You just want to set them equal to each other. You're literally just going to go 2x minus 17. 2x minus 17 over 3 equals 11. Boom, 25. Yeah, that's basically it, right? 2050 minus 17, 30. Yeah, I mean, those are pretty straightforward. Okay, sorry, a little too easy in my mind. I guess from all the difficult problems, this was a nice refresher. This situation, you have 3. The only way to do this on Desmos, you like doing this by hand would take you forever. I mean, I guess it's possible to do it by hand. I shouldn't say you can't do it, but it would be insane to do it by hand, in my opinion. Hit the plus sign, table, plug in all your points 0, 4, 1, 9, 2, 20. And I just want to create the equation. Non-linear, because this is definitely quadratic. And boom, 3x squared plus 2x plus 4. And that's C. Cool beans. Next. 4, I get this. What is the sum of all possible values for B? Okay, so you have to look at points for -3. So that's -1 and 5. So -1 plus 5 is 4. Too simple. 3. And again, remember, they go from easy, medium to hard. So questions like 1 through 5 are going to be really easy, relatively easy. Scatter plot shows a relationship on the line of the best fit. Which of the following best lines of the best fit shown? So you have to see which one fits. Just see which one fits. I would like graph out each one and see which one looks about right. And I would just get rid of anything that doesn't make any sense. Like C and D, there's no way that would make sense because the y-intercept, you can clearly see the y-intercept that would be like 7 something, right? So clearly if the y-intercept would be 7 something and the slope has to be negative, I mean, I don't have to do anything. The answer is clearly B, but I'll just prove it to you. Y equals 7.312 minus 0.384x, right? I mean, it clearly works here. Everything fits. It's got to be B. And again, slope is just negative and y-intercept is positive, so you only have one answer like that. But just in case you had something, you would plug in points, and if they gave you points, you just shove it into Desmos and just get it from there. It's pretty straightforward. Next. It takes the tailor 4 hours to make a shirt, 7 hours to make a pair of pants. The tailor works a total of 56 hours in a week. Okay, in this situation, you just have to create an equation for this. You can plug in numbers for this as well. If we are making an equation, tailor makes 2 types of garments, shirts and pants. It takes the tailor 4 hours to make a shirt and 7 hours to make a pant. So 4x plus 7y equals 56. Cool. And then x plus y is 56 hours, which equation represents total number of shirts. Okay. These 2 types of, it takes the tailor 4 hours to make a shirt and 7 hours to make a pant. So it works for a total of 56 hours in a week. Oh, that's it. That's all we know. Shirts X and pants Y. That's it. We don't have any other information, so I don't have anything about X and Y. Okay, that was easier than I thought. Sorry. That was fairly straightforward. Well, oh, 4. I'm sorry, I wrote it wrong. Well, anyway, be careful with that. Make sure you're double checking your work. And last one, number 1. Club has 80 members. A sample of the club members was selected at random and asked whether they prefer online or in-person meetings. Online or in-person. Okay. Of those surveyed, 40% responded that they prefer online meetings. Based on the survey, which of the following is the best estimate of the total number of club members who prefer online meetings? Online or in person? Best estimate of total number of club members who prefer online meetings. Okay, it's 40%. So, if, okay, am I crazy, or is just 0.4 times 80, which is 32? Yeah, it looks pretty straightforward to me. All right, whatever. Anyway, guys, we're gonna stop for today because I was supposed to go from 7 o'clock to 8:30. Normally, I would. I don't want to start on a brand new section. Next week is gonna be hopefully a lot more organized because I'm gonna spend more time testing and breaking it down. We're only gonna get better over time. At least I got to get chat working this time, so it is what it is. Okay, for this live was not exactly a great success. Last live was a lot better because we had no technical issues, which was kind of nice to doing our first live. Next week we're gonna go hardcore, so please do me a favor and subscribe to the channel if you want to see more content like this. I'm going to be posting more and more and more, and again, hopefully we won't have any technical issues next time. Anyway, I'll see you guys next week.